we'll start. Probably this one's for Jake from Alex Longo. The stated walkback distance and slope limits for XCVAS are 2 kilometers and 20 degrees. Will Artemis 2 use the full extent of that capability, or will lower limits be set since it's the first mission? If so, what will the Artemis 2 limits be?
Yeah, thanks, Alex. That's a really good question. And Artemis 3 is our first time landing in the South Polar region of the moon. It's our first time to have astronauts on the surface of the moon in over 50 years. I think it's important to remember when we say 2 kilometers, that's a distance that we cannot exceed for safety reasons. Artemis 3 is basically our first chance to test kind of a multi-system integrated solution for communications on the surface for safety. So we're going to do the best we can. We can't go past 2 kilometers. That's our walkback range. And we're gonna maximize that as best we can, but learning how our systems work so we know where we need to improve upon them going forward. I don't think we're going to set a limit that says we can't go anywhere farther away within that 2 kilometer range, but we're really going to be testing out that system so that we can understand what we can do. But I can tell you, ESDMD has heard very clearly from SMD, we want to go as far as we can. And so our job is to try and do as much of that as we can on that first mission.
Yeah, I think that's great, Jake. And I realize that, I think we all realize that Artemis 3, we're going to be testing out a lot of stuff, but we're going to keep building on that as we move to future missions. And so our capabilities are going to grow over time, which doesn't mean we're not going to do awesome science in Artemis 3, but there's even better science to come.
Yeah.
Let's see. Jack Schmidt asked a question that I think I've heard a number of people ask. So I'm gonna point it towards Anne. What is the backup plan for the elevator?
That's a good question. I'm not sure I know the answer to that. If there's anyone else from HLS on who does know the answer to that, I would happily defer to them. But the design of the elevator, it's not something I've been following super closely in my role as utilization payload team lead. But I am certain that there will have to be a number of fail safes in there. I don't know that there is an alternate way to get to the surface if the elevator is not functioning.
That is something that we're working with HLS from an EVA community standpoint. I don't think we have a final solution or something that we could talk about here with this community today, but it is something that we are working on with our HLS counterparts.
Great. I'm trying to read through Jack has a lot of questions here. Jack, a number of these questions will be answered later today. We've got talks later today talking more about tools and about the training and other things. So I think a lot of your questions will eventually get answered. So stay tuned.
Yeah, Sarah, I agree. I threw a few notes on the side. I think we'll answer a lot of those from Dr. Schmidt. He mentioned one about lighting, so if it's okay, I'll touch on that really quick because I think Dr. Schmidt, you had a few questions around lighting, and I'm sure I'm not telling you anything new, but for everyone on the call, it looks like we have 208 participants. NASA engineers and lighting experts have gotten together. They've actually had multiple workshops through the NASA Engineering and Safety Center. We refer to that as the NESC. We've had multiple workshops specifically on lighting to talk about lessons learned from Apollo, to talk about all the testing and the different laboratory work that's been going on since, and to just get that community of experts to sit down in an integrated workshop to talk about lighting from all the different angles, from vehicle lighting, from natural lighting environments, to make sure that we were asking the right questions, not just from within NASA, but from the entire community of industry and academia as well. So I think we're asking the right questions. I appreciate the comments in the chat. I know we've talked about those before as well. So
yeah, and if I can just add on there, this is one of those great examples about where science and exploration are intimately intertwined, because it's the knowledge that we have from, for instance, the Lunar Reconnaissance Orbiter about those lighting environments, so that we have some idea what to expect. And I've said this at various meetings in the past, but it's really important to remember, because I hear people say sometimes the lighting at the pole is hard compared to the equatorial regions, and it's not that it's harder, it's just different. the nice thing is we can identify locations where we don't have to have batteries as large if we want to survive multiple years. But it is a repeated pattern. And because of the science that we already know, collected from LRO and other spacecraft, we have a pretty good idea what that pattern is like, so we can plan around that pattern. So this is what we mean when we talk about science and exploration going hand in hand. And that's why I refer to it as the backbone around which we wrap the architecture, because if we don't have that knowledge, we have to over design our systems in ways that make it harder, as Sarah was pointing out, to take those next steps and do more and more. So, keep doing all that science research out there so that we have a better understanding what that environment is that we're planning for, so we can find the right solutions.
All right, let's see. There's another question from Jack on where will the EVA and science support teams be located on Earth? It's another question we're going to touch on later this afternoon, but we are working on building those science support systems and operations at JSC and in the mission control. So the science team will be in the same building and able to communicate and work with mission control. Anybody wants to add anything to that?
Yeah, I can add to that too, Sarah. I mean, Artemis is going to become something that's, a year-round activity at some point. We'll have payloads, we'll have rovers that are active. So it's maybe a little different than the Apollo model of thinking about where the science support will be, because I think we're rapidly going to enter into a situation where the science support is a year-round activity and it's hosted in many different locations. So we may start at the very beginning, with what we know from Apollo supporting those crewed missions, but between CLIPS and LTV and other assets that we put on the surface that are reusable, we're going to have to be looking at models about more distributed networks of support.
Yeah, that's really exciting, Jake. Within the EVA and Human Surface Mobility Program, that's a challenge just to make sure we have that mindset that the mission doesn't end when the crew leaves the surface. We're planning these surface assets like unpressurized and pressurized rovers to do science and gather data the entire year, and obviously outside of just the crewed portion of the missions. And I think science, is one of the major cornerstones of what we're planning to do. So, like Jake said, it's an exciting and fun challenge that if we're talking about EVA science support, that's really just one small piece of the much bigger picture that we're excited to participate in.
Yeah, that's right. Just like we were talking earlier, we're gonna build on our capabilities, and they're gonna continue to grow over time. I don't know who to address this to, but there is a new question in the chat as how will you handle space weather like solar wind and CME events? Is there anybody who would like to jump in on that?
I mean, we're going to be learning how to deal with those over time. So first, Nikki Fox was speaking at the very beginning about heliophysics and monitoring the sun. I mean, the science we learn about the sun with the entire heliophysics fleet is basically the weather forecasting, that we have for the sun that will help us understand how to deal with it. We do have, various approaches to kind of sheltering inside the habitats that we have or the vehicles that we have. But those are certainly things that as we spend more and more time in space, on the moon, around the moon, we're going to have to think through how to develop that, because longer durations in space increase the likelihood you'll have an encounter with a situation like that, and we'll need to be prepared for it.
All right, and with that, I think we will close out the session.